Let's start section 3.1. Let's talk about quadratic functions. And specifically, we want to graph a quadratic, and we also want to be able to find the vertex of a quadratic function. So before we get to the graphing and the vertex, let's just talk about what a quadratic is. So there are two ways to write a quadratic function. The first is called standard form, and it looks like y equals ax squared plus bx plus c. And that's the form that we're familiar with from earlier in the course. And there's a new form which is called vertex form. That's interesting because one of the objectives is to find the vertex, right? So anyway, vertex form looks like y equals a times x minus h quantity squared plus k. And we'll talk about that some more in just a minute. First, let's talk about examples of quadratics. So the first example would be the basic function y equals x squared, which we studied in chapter 2, and we know that the graph is a parabola that opens up with vertex at the origin. And the next example I want to look at is y equals x minus 3 squared plus 16. And specifically, what I'd like to figure out is where is the vertex this time. And we learned in chapter 2 about transformations of the basic functions, transformations of y equals x squared, for example. We can use transformations to find the vertex of this new parabola. So, do you remember how the minus 3 inside the basic function affects the graph? The minus 3 represents a shift right 3. And the plus 16 is outside the basic function. It represents a shift. So actually the problem that I wanted to do was not plus 16 but minus 16. So let me see if I can find my eraser and my blue pen and change that to a minus sign. Okay, we got it. Okay, so now the minus 16 is outside the basic function, and so that would represent a shift down 16. So what does that do to the vertex? Well, the vertex started at the origin at 0, 0, and then went to the right 3, so that's a positive 3, and then down 16 would take you to negative 16. So the vertex now is located at 3, negative 16. And that's a nice result, and we'll practice that some more in the examples to come. But first, let's back up and let's go back to vertex form now. So you see that the example we had was in vertex form, and you see that the 3 represents the x coordinate, and the minus 16 represents the y coordinate. So what are the x and y coordinates of the vertex here in this formula? Well, the 3 is replaced by h, and the negative 16 now is replaced by k. So the result is vertex at h comma k. Does that look okay? The plus k is a vertical shift. The k, if k is positive, we're going up. If k is negative, we're going down. So we take k and the sign in front of it. So 16 and the negative in front of it is the y coordinate. And then remember, when we're doing transformations in the horizontal direction, everything is a little bit backwards. And so the minus 3 over here in our example becomes a plus 3. And similarly, the minus h becomes a positive h, or it's the number after the minus sign in the vertex form. Okay, with that said, we're ready to get into the first example. Well, let's dig a little deeper with the example we already have. So let's look at x minus 3 squared minus 16, and we'll get its graph. We'll go from start to finish. We'll find the intercepts and the vertex we've already talked about, and then the axis of symmetry. And then we can put all that together to make the graph. So do you remember how to find the intercepts? If you want to find a y-intercept, you set x equal to 0, and you solve for y. And so then that would give us f of 0, right? In function notation, x gets replaced by 0, and then in the formula, 0 minus 3 squared minus 16. Negative 3 gets squared to make positive 9. 9 minus 16 is negative 7. And so we can write our y-intercept as an ordered pair. X was 0, and the corresponding y was negative 7. Okay, so if we want to find the x-intercepts, the process should be similar. We should set y equal to 0 and solve for x. And of course, where is y in our formula? Y is f of x. So in the formula, f of x gets replaced by 0. We could write 0 equals x minus 3 squared minus 16, although usually we would just write the equal 0 at the end. So we would take the formula x minus 3 squared minus 16 equals 0 and solve for x. So does it look like we set y equal to 0 there? Okay, let's go ahead and solve for x. There's more than one way to do it. Maybe the quickest way would be to add 16 to both sides, and that would get us x minus 3 squared equals 16. And then the square root property tells us that we can drop the square on the left if we insert a square root on the right and also a plus or minus. So now we have x minus 3 equals plus or minus 4, or x equals 3 plus 4. Right? Add 3 to both sides and we get 3 plus or minus 4. 3 plus 4 is the first answer. 3 minus 4 is the next answer. X equals 7 or x equals negative 1. And we found the x-intercepts. If we want to write them as ordered pairs, 7 comma 0 is the first one, and negative 1 comma 0 is the second one. And we should be able to box that up. Okay, let's go ahead and find the vertex again. We said we're in vertex form, and so we can just read the the vertex right out of the formula. We already know what the answer is, but let's go back through it one more time. So we see x minus 3 quantity squared. So the minus 3 is going to change sign, and it's going to become a positive 3. And the negative 16 behind is the y-coordinate, and it doesn't change sign. It remains negative. And so we have 3, negative 16. We can box that up. Okay, what's the axis of symmetry? The graph is a parabola, so the left side of the parabola is a mirror image of the right, and vice versa. And so the line of symmetry is a vertical line through the vertex. The axis of symmetry is the vertical line through the vertex. And so a vertical line through 3, negative 16. Remember, if we want to write an equation of a vertical line, we start out with x equals, and then whatever the x value is. So x equals 3. Okay, let's go on to the graph. We're going to plot the points that we found and connect them up with a nice parabolic shape. So I was careful with my scale here to make sure all the numbers would fit on the graph. You can see in the y direction I counted by 2's, 2, 4, 6, 8, 10, 12, 14, 16. And of course I didn't write the number at each tick mark. I went every other tick mark and wrote in the 4, 8, 12, 16. And then in the x direction I counted by 1's. 1, 2, 3, 4, and so on. But again, I only wrote the number for every other tick mark. Okay, so we can go ahead and plot the point at 0, negative 7. Be careful, it's going to be right in there, right between negative 6 and negative 8. And that should be good. And then we can find the x-intercepts at 7, 0, and negative 1, 0, and the vertex at 3, negative 16, right down at the bottom of the graph. And then we could even draw in the axis of symmetry. We would want to draw it as a dashed line, not a solid line. And we could label it x equals 3 right on the graph. And then remember the right is a mirror image of the left side of the graph. And so let's take this point at 0, negative 7, and let's flip it over. Where does it wind up? Well, from 0, negative 7, we count over 1, 2, 3 units to get to the line of symmetry, and then we count 3 more to find its new location there at 6, negative 7. And so now with those 5 points on the graph, we can connect them up with a smooth curve. And we're done. We'll go on and see some more examples in the next videos.